So on this one, express a trig function of one angle. Does anybody see anything, first of all, about the angles? Yeah, they got negatives. You got to get rid of those. So if there's a negative in the sign, where does it go? Out in front. Negative sine of 5, cosine of 2. And this one also goes out in front, doesn't it? Minus cosine of 5, sine of 2. Now, do you have any identities that have a negative negative in it that have sine and cosine together on the right side? You look. Nice. Yeah, if you had negative sine of 5, cosine of 2 plus cosine of 5, sine of 2. Now you do have a plus sign for sine and cosine. So sine, cosine, and cosine, sine. So it works. So you have sine of. Now for sine, is it a plus between the 5 and the 2, or is it a minus? Plus. Add them together, you still got the negative out in front, so it's negative sine of 7. Okay. There's lots of ways that you can do that one. That's just one way.
Wait, why would it be the sine of negative 7? Would it be the same thing?
It would be. If you had the sine of negative 7, where can the negative go? In the front. Okay?
It's the same because that's the identity, right?
Exactly. It is the same because it is the identity.
So you're solving for sine, not one, not cosine?
No, you're just trying to use the identity, and this identity happened to be sine because they were mixed together. If it was a cosine, cosine, our answer would say cosine on the bottom. All right? No, not today. This one says cosine, cosine. Oh, wrong way. Sorry. Going the other way. This one, put an asterisk next to these. These are guaranteed to be on your test, if not once, definitely, or if not, definitely once, maybe twice. So, it says for the second quadrangle, do you remember what this letter means? We just call it what? Capital A, and this one stands for capital B. Angles are capital I, sides are lowercase. So the person that knows that the second quadrant is A, you write this picture with an A, and you label it with a 24 and a negative 7. Oh, sorry, got that backwards. It should be, I was looking at the wrong trig function. For tangent, it should be 7 is the opposite. Negative 24 is the adjacent. And this is angle A right here. So hypotenuse is going to be 25, I believe, if you do the Pythagorean theorem. Then it says for B, that's going to be a third quadrant angle. So I draw my third quadrant, draw my angles, and I label it. Negative 3 is going to be the adjacent side. And the opposite side will be negative 4 with hypotenuse of 5. What you're doing is you're getting them set up. It says A plus B. You cannot add the fractions because of the ratios. These are angles. So you have to expand this because we don't find the angles, add them together and take the sine of it. We have to expand it so we get to learn how to use the identity. So we write sine of A, cosine B, plus cosine A, sine B. This is for question number A.
Question number A?
Yeah, or question letter A.
I said that all the time.
Sine A, cosine B, cosine A, sine B. And then from each picture, you just put in all 4 fractions. The other day, yesterday, you used the unit circle. Today, you're using 2 different pictures. For A, or the sine of A, you go to the A picture, write down the sine, 7/25. Yeah, the opposite of hypotenuse. In A, you see A right here? Opposite over hypotenuse is the sine. This one says go to the B picture and find the cosine of it. What is angle B? I use my reference angle, and the cosine of it would be what? Yeah, it'd be negative 3/5. Adjacent over hypotenuse.
Where's that?
Negative 3/5. What's the cosine of A going to be? Any ideas? Yeah, negative 24 over 25. And then sine of b, yeah, it would be negative 4 over 5. Opposite over hypotenuse, adjacent over hypotenuse.
You want us to multiply by
Yeah, then you multiply them out, you got a calculator. So it's negative 21 over 125, and 24 times 4 is 96, I believe.
So what would be negative 21 over?
Well, 7 times 3, okay? So you got the 125 right here. That turns out to be 5. Hey, this is going to be nice. 3/4? There's no way you get that answer unless you did a lot more work without using the identities.
How do you get negative
3/5? Sorry. 3/5.
Yeah, how do you get the negative 4/5 and the sine of b?
Oh, I got the negative 4/5 from the problem. This problem right up here. It says the cotangent is 3 over 4 in the third quadrant. That means the adjacent side is 3 and the opposite side is 4. Hypotenuse has to be 5. And the third quadrant means they're both negative.
That's right.
All right? See, this one's not difficult. All you got to do is, the hardest thing is maintain that logic for more than 2 steps. This isn't factoring in Algebra 1.
Just take it through B2.
B? Yeah, then you do B. But you already drawn your picture for B. For B, you just use a different identity. What is cosine of A plus B? What identity is that? Yeah, it's cosine A, cosine B, minus sine A, sine B. And you put in your fractions. Well, we know the cosine of A is going to be negative 24 over 25. There's an easier way of doing this, but that's okay. We'll talk about it later. Cosine, you wouldn't get it yet. Show you now? Sure. You see how these are the same angles, A plus B, A plus B? We have an identity that says sine square root of theta plus cosine square root of theta equals 1, don't we? So that means if I take 3/5 and square it, I get what? 9/25, don't I? So 1 minus 9/25 is what? 16/25. I take the square root. So cosine of A plus B equals 4/5. Sine squared plus cosine squared equals 1. If you don't see that, obviously you can multiply it out. 7/25. Sine of B is negative 4/5. If you don't see the sine squared plus cosine squared, you can go that route. This is going to be 72 plus 28 over 125, which will boil down to 100 over 125, which is 4/5. Nice. Yeah, I do too. That shows a little bit of intellectual thought when you go the Pythagorean theorem route. Yeah. Fantastic. We're moving on. Ready? Moving on. This one we've already done. What identity does this call for? Chris? What identity? Is it sine cosine or cosine cosine?
Sine, cosine.
You don't know? You don't have the identities written down? Or you do? All right, well, this one is sine of u minus v. This is u. This is v. So it's going to be sine of u, which is theta, cosine v, which is 3 pi over 2. Now, everybody says, what about the negative? That's included in your identity. You put a minus sign right there. And then you put in cosine theta, sine of v.
So wouldn't it be plus?
Sines are the same. Cosines are the opposites. So, what is the cosine of 3 pi over 2? Let's see. Matthew? Yes, it is. And what's the sign of 3 pi over 2?
What would you do there?
I went to the unit circle, went to 3 pi over 2,
Oh, -1.
and it's -1.
Yeah, but I don't remember if that was.
You don't know how 3 pi over 2 works on the unit circle?
No, I just don't know how we got from sine, cosine, minus cosine, sine, all the way down to sine minus cosine.
It's your identity.
Oh, this one. That is a number.
We'll plug it in. So how do you know what, if you're, since sine's theta, so if cosine was theta, you get sine,
Right.
and then vice
Where's your-
versa.
Right. Where is it?
Because you have sine theta 0 minus cos -1.
Right, so that gives me positive cosine of theta.
That's what I
And that equals cosine of theta. Checked, done, marked off, moving on.
So,
What?
I just don't get that.
Do you have a unit circle?
Yeah.
Look at 3 pi over 2.
I know, I get that,
Okay.
but where did you get, like, I just know.
We're going to get what?
I get the first step, that sine, cosine, minus.
Right.
Where did that second step come from?
Punch in the calculator.
The cosine of 3 pi over 2.
Right.
Zero, but.
Yeah. 0 times anything is 0. And the sine of 3 pi over 2, if you punch it out, is going to be -1.
Okay.
All right? No, we don't have time.
Yeah, we do.
Oh, no. We don't have to do that one. We already did it. Here we go. I like this one. Verify the identity. Once we get caught up today, we'll be able to take a brain break tomorrow. No, how about just this one? Verify the identity. There's a good choice, and there's a bad choice to start. Depending on how strong you are, there's an obvious choice. Now, I still don't understand how people can't see this as identity for the left-hand side. I know. You see how you have two angles added together? Are they different? That's what this says. Two different angles added together. Okay? That's what it says mathematically. Yeah, it'd be cosine theta, cosine pi over 4. Sine of theta, sine pi over 4. Now somebody said, well, what are you trying to get to? Oh, you're trying to get to the right side.
Oh, we're doing identity.
Yeah, see, it says identity.
Oh, you're kidding.
They're awesome. Sure, what's cosine pi over 4?
Oh. Well, wouldn't it be cosine plus? Or cosine theta plus?
Good.
Because cosine opposite.
Look at that. The cosine pi over 4 is root 2 over 2, so there's a sine of it. There you go. You factor it out and you're done with the problem.
Can we say like that then?
No. You have to match each side.
I actually understood that.
Good.
Yeah, I get this lesson. I'm smart.
Hey, we did a problem in second hour today, and I'd say over half of them got it right. That was good.
Is
Let's see.
there supposed to be a minus?
There's a minus.
Yeah, okay.
Okay?
I don't get this.
You keep saying that.
I don't get this.
So how does cosine minus sine equal
I get the other ones.
the root 2 over
The
2?
reason this
You factored both of those out.
right.
This is just factored.
So you don't really even have to write cosine.
Yeah, because you have to match the other side once you answer. Right? All right, here we go. Not that one. That was too easy.
No, it's not.
Okay, it's not. All right. Let's go with, I don't know. Who wants to give this one a shot? Which side do you want to start on first? There's a great side and a not so great side. Which one's that? Yeah, I'll go to the left. No, I have a meeting. It must be 3:15 or 3:50 or 2:50, I mean. Yeah, it goes off in 15 minutes. I gotta go meet somebody. I hate that. I don't want to meet them. Maybe I'll tell my phone didn't go off.
You're sick. That's hell.
Yeah, we are.
Well, you have to have it.
Oh.
Yeah, it was Frickin's call me. Please record the lesson. He won't listen.
There's no way he's gonna get on this, you know that.
I'm giving him the opportunity. All right, there's a sweep move you can do next, or there's the average move. Yeah, there is. There's like a move like, ooh, nice. Yeah, what is it? Yeah. If you haven't learned this move by now, I've been trying to show you since September. You're just going to go the other way. That's all there is to it. I'm about to cut you loose. Go on your own. Good luck.
If you do like cosine A, cosine B, if you do like cosine
I want to get rid of both denominators at one time.
A. But is that a B or is that an A?
That's a B. So take a look at the numerator when you multiply it out. You multiply by 1, and you get that. You multiply this expression by the first fraction, the cosine A's will divide off. Yeah, sine A times cosine B, plus, so yeah, sine B times cosine A. Now, just wondering, what do you think that equals, the denominator?
Probably sine
Very good. Look at your answer. You always have to keep track of your answer when you're doing these. It is. You're all done. Last step. Because instead of U's and V's, I used A's and B's.
You just pull a sign out then?
No, use your identity. This is the right side of the identity. And this is the left side of the identity. So you have sine of A plus B. You didn't factor anything, you just looked. This is the right side of the identity, and that's the left side, so they equal each other. And you just made the substitution. Yeah, it is.
And that's relaxing.
This is relaxing. This question right here. This is a high dollar question right here looking at you. This one will be solved on the test by 15 to 18% of you. Oh, yeah, we do. I can get done in 2 minutes. All right, does anybody see anything, first of all, that we need to address?
Change them to X's.
No? The negative. Not yet. I'll change them to theta in a minute. Now, does anybody have, you see a cosine here? What's it missing? Plus or minus what? Sine. So if I take this over the other side, yeah, I have cosine 5t, cosine 3t, plus sine 5t, sine 3t equals a half. This brings it all together. This is like the Hakuna Matata, circle of life, whatever you want to call it. Yeah, it's a half. You can read. Half. A half. Yeah, you can read. Oh, so how do you rewrite this identity now? All right. Now I will here's your let statement. Remember, anytime we use a let statement, you're going to have the plus 2 pi n to generate the solutions.
So what happens to your sign?
They all 4 of those went into one identity.
So do you add 2 pi to your half?
Close.
You add 2 pi to
If you let theta equal 2t, 5 minus 3 is 2.
Okay.
So you have cosine of theta equals a half. Where is that true at? Excellent. So theta equals pi over 3, and theta equals 5 pi over 3. And I said when you're using a let statement, you have to add your solution generators onto it. 2 pi n. This is relaxing. This is the way to end the day. Feeling good about yourself. Knocking off one of the big dog problems in the whole chapter.
Okay, how do you
Wait,
get
so where did that come from? So you don't-
Oh, because on the unit circle, a half happens at pi over 3 and 5 pi over 3. Why do what?
if you put 2t equals 5 or 3?
Yeah, now I put exactly right, Beamer. 2t equals pi over 3 plus 2 pi n. And 2t equals 5 pi over 3 plus 2 pi n. We're getting close.
And then you divide by 2.
Yeah. Pi over 6 plus pi n and 5 pi over 6 plus pi n. Your solutions come from 0 to pi. Thank you. This is our solutions generator. So when n equals 0, I get what 2 answers? Oh, yeah. Oh, I'm only going 0 to pi, so I'm done.
Yes, thank you.
Darn it!
I hate those.
Yeah, I did.
Like you got saying. So when it's a let statement,
Yeah,
you add 2 pi.
you betcha.
How do you know when it's a let?
Well,
Does it say it?
Because whenever you change the period
Through 57.
of the problem or phase shift,